If you've ever considered adding a proof meter to your expensive machine tools to help track lubrication schedules and other maintenance chores, stay tuned. In this video, we'll go step by step through installing a hardwired hour meter in a stationary power tool to take some of the guesswork out of servicing the machine. This and more right now here on Shop Tales and Lore. Traditionally, agricultural and industrial power equipment, as well as machine tools intended for commercial applications, have come with factory-installed proof meters to register operating hours. Apart from this basic function as a sort of odometer that records time, proof meters are a valuable aid for staying on top of preventive maintenance. Care of tools that require little maintenance, like a few drops of oil now and then, can easily be managed with something as simple as a calendar. But when we learned that maintaining this new wood planer involves 3 different lubricants and 4 distinct service intervals, we knew that adding an hour meter was not just a good idea, but a critical step in the tool's efficient upkeep. Hour meters can range from simple, self-contained, battery-powered types that digitally record and store the relevant data to electromechanical designs that are basically quartz-regulated clock movements. They come in a wide range of shapes and mounting systems, and most AC models accept a wide range of operating voltage. Specialty designs are available for most any operating environment, including corrosive, dusty, outdoor, and even submersible applications. For most outdoor power equipment and some machine tools, these inexpensive vibration-activated meters work just fine, but some tools may not produce enough vibration to reliably switch on the meter. This was a concern with the wood planer, so we decided to go with a hardwired electromechanical type that would be energized whenever the machine is switched on. This one seemed like a good candidate for our purpose, and I believe it was less than $15 on Amazon. We'll leave a link in the description. After shutting off the power to the planer, the next step was to figure out the best location for the meter. This switch housing turned out to be the perfect spot, with more than enough depth for both the meter and the existing switches, provided we installed the meter through the back of the housing. The instructions call for a panel opening of 49 millimeters, or about 2 inches, but before punching any holes in the planer, we made a mock-up panel using some scrap 1/4-inch plywood to test the fit. A 2-inch hole works just fine. Using a 2-inch hole saw to gauge the best spot for the opening, we marked the center of the location and drilled a small starter hole to help keep the hole saw's pilot bit from walking. Even though the material in this case is soft steel, we kept the hole saw at low RPMs and used plenty of light oil to both protect the saw and to help ensure that the hole will have a smooth edge. Hey, speaking of handy tips like this, if you're a serious do-it-yourselfer or home workshop enthusiast looking for a variety of helpful content in one place, hit that subscribe button and ring the bell to be notified whenever we release a new video. And if we've helped you today, please take a moment to like, share, and comment below. It helps these videos reach more folks, and your comments help others as well. Thanks again. Now back to the video. The next step was to decide where to tie into the machine's circuitry to energize the meter. A cautionary note here. Machine tool wiring, motors, switches, capacitors, junction blocks, and other electrical components can differ widely from one machine to the next, even when built by the same manufacturer. If you're the least bit uncomfortable working with or around electricity, consider having a qualified electrician handle this part of the project for you. In our case, with this specific machine, we looked at several options, including connecting to the magnetic switch inside the lower cabinet, but in the end we went with the simplest approach and kept everything contained in the switch housing up top. Initially, we tried tying into just one side of the planer's 240 volt input, with the meter's negative side going directly to ground, but this caused a conflict by overriding the kill switch. Because our meter accepts a wide range of input voltage, we ended up connecting it to the two hot legs of the incoming power cord for a total of 240 volts AC. Again, use extreme caution or get qualified, knowledgeable help when planning, testing, and making these connections. Your machine's circuitry is almost certainly different from this one, so don't take any chances with your safety. Finally, we connected and installed the meter itself by first feeding the two leads, fitted with appropriate crimp terminals, through the meter's retaining ring and through the hole we drilled in the housing earlier. Then it's just a matter of connecting the leads to the meter. Note that this meter is polarized. Placing the meter in position through the hole and fastening it in place with the retaining ring. Here's a look at the final installation, and with the action sped up just a bit for the sake of time, a check of the meter's basic function. Hey, thanks for watching. Here are a couple more videos you may find helpful. Be sure to visit our homepage for many more DIY and home workshop topics.